Everybody, welcome to today's webinar and discussion. As it's already actually 1 minute past the hour, we're going to actually get straight into it. So we're here to talk about best practices for generative AI risk management and prevention. My name is Nick Patience. I am managing analyst for data AI, InfoSec and risk at S&P Global Market Intelligence, and I was a co-founder of an analyst company called 451 Research, which has been part of S&P Global now for almost 4 years. And so the flow of today is I'm going to walk you through some of my sort of scene setting slides and thoughts about what's going on with generative AI and risk management. And then I'm going to turn it over to the folks from Robust Intelligence and Databricks for a brief presentation by then, and then we're going to get into the meat of it, which is going to be a discussion between the three of us. So it's going to be myself, and then Koji Noshiba from Robust Intelligence, and then Nitin Wagh from Databricks. So for my part of the presentation, I'm going to talk very briefly about use cases of generative AI, and then get into your main part, which is really about the governance and security aspects before we get onto the other slides and then the presentation. So there's lots of, obviously everybody here knows what generative AI is by now. There's lots of different ways of framing this and thinking about how it changes things. I'm sure everybody's lives have been changed somewhat since November the 30th of last year. And it's interesting to think about how it changes the way we work. But here we're also to think about how it changes security and risk management and examine some of those things. One of the ways I think about it when I'm talking to enterprises, large and small, is think about, we've shifted from purely pattern classification into the kind of age of content generation. That obviously doesn't mean that the pattern classification of the traditional machine learning use cases goes away in any way. It doesn't. But now we've opened up a whole nother set of opportunities, and you might say a whole nother set of risks as well. Another way of thinking about it and framing it at a high level is we're going from narrow to broad. And what I mean by that is the last sort of big wave of enterprise AI in around 2016 period. We had a lot of kind of interest in, this is going to be revolutionary technology, it's going to be very broad, but then the use cases got quite narrow. The models will get very specific because they're based on organizations' data, and they're trying to solve very specific problems. Excuse me. The potential for generative AI is for it to be a general purpose technology. And general purpose technologies like electricity and things like that obviously have very, very broad potential. So that's the way it looks at the moment. That may change, but that also then obviously has implications for risk management, which is the main thrust of what we're talking about today. So it's very, very early days, and this is one of our Voice of the Enterprise AI machine learning surveys we do. And we simply asked a very, very basic question at the moment about whether organizations are doing something with this, investing in it in some sort of sense of the word. And 2/3 of them say they already are. And this survey was run in May and June of this year. We're going to do much more detailed breakdowns of use cases. We also asked them at a high level where they've grouped some of the use cases they've seen so far. And this is what they told us. This was mainly more of an IT decision maker audience, so IT service management and threat detection came very high. And then you have the more common ones around sales and marketing, customer self-service, workforce productivity, but all of them are popular options. The threat detection one is quite interesting, I think, as a use case. Obviously, we're here to talk about the threat in a sense of generative AI, but threat detection of a use case for generative AI is another aspect of it. You kind of think of it, again, as one of these big summarization problems. Most use cases we come across fall into three broad buckets with generative AI. You have the content generation, which could be for marketing purposes or anything else. You have the summarization challenges and solutions where summarizing large volumes of disparate data and getting it down into more manageable chunks, as it were. And then you have some sort of information retrieval, knowledge management, search kind of challenge that organizations are grappling with. And then you can break them down by industry and other things. But all of them are potentially interesting, and all of them are doing something different. And also, that doesn't mean that, as I said, traditional machine learning goes away in any shape or form. It doesn't. And we obviously see, like I'm sure a lot of you do, a lot of interest to kind of grasp at the kind of generative AI opportunity when sometimes the actual problem might be more suitable to other traditional methods. But that's what happens when you get to one of these kind of major platform shifts. So let's have a quick think. I mean, what I'm seeing anyway with myself and my colleagues, the analysts at S&P Global Market Intelligence, in terms of the governance and security challenges that are thrown up here. First of all, when we're now Voice of the Enterprise survey, we actually asked for the top concern for AI and ML infrastructure managers, and actually theirs was security. And so overall, 46% of respondents chose security, and then 21% said if we had to pick one, that would be our top concern. And so it's clearly an issue, and I think it's one of these things. And one of the things we're going to get through today is, well, what is the issue specifically? What are the challenges organizations have, and how might you be able to mitigate the risk? So generative AI faces and produces distinct security issues compared to any other form of AI and ML we've come across before. There's security in the development process, which is probably is fairly standard in terms of other forms of AI, both in the development and deployment process, but also in the software supply chain, where you're thinking about open source and other areas like that. Then there's security in the operation, and so both in the traditional vulnerabilities you get in any environment, exposures and implementation, systems configurations, all those kinds of things. And then the training of models, there's a danger of data leakage, model poisoning, and some sort of exposure through the actual training data. And then the interactive nature of it. That's the kind of key point here. It's the security against unwanted or malicious input or output. And that is where it does differ from previous waves of AI and ML. So thinking about that dynamic security threat in a bit more depth, it is dynamic, like other forms of ML and AI in general. It has capacity to learn, but each interaction might be unique, and that makes using kind of traditional deterministic controls quite difficult. And large language models may no distinction in input between content and control. Here we mean conversation can also include directions for generative AI to take unwanted actions, embedded URLs, and those kinds of things. It's not just about writing poetry with these things. And then thinking about the manipulation of input, this is already an area where both the industry and in research is really digging into this issue. Because the susceptibility of large language models and other kinds of foundation models, this is not just about language. But you think, if you train a model on language, that's one thing. Then you can train a model on medical data or sensor data or code or anything else. There's definitely other issues there. And this is an area where researchers can help identify weaknesses and developers mitigate exposures. And I'm sure you're aware of the DEF CON challenge that happened in the summer, and then OpenAI is talking about red teaming, and then Google's red team as well. And so there's a lot of activity here. There's a lot of concern that DEF CON we were not going to find out the full results of the challenge, I don't think, until February, but there was a lot of interest at that. And then let's talk a little bit about the output risks. Data leakage and exfiltration. Prompts can be manipulated to output sensitive or inappropriate data. This top right-hand one there, article there, that's from the NPR's report from DEF CON, and one of the people who turned up there and saying it was his first time, and he just told the AI that his name was a credit card number on file, and it asked him what his name was, and it gave him the credit card number back. So so there's a lot of ways of doing this. So we're talking about malicious content, disinformation, misinformation, malware generation, and different attack tactics, deep fakes, obviously, and then embedding malicious code inside images. All these things are output risks. And then community is responding to this. So there's a lot going on, and I've only got kicked off there. So there's lots going on here. There's lots of work going on in the industry, both in the public sector with NIST and the NSF, and other things like that. And then in the private sector, so there's obviously things, conferences like such as RSA and Black Hat. There's a lot of spotlight on this subject. So with that, I'm going to hand over. I'm going to hand over the reins now. So we're going to talk about robust intelligence and what they can do.
Awesome. Oh, first of all, hi everyone. My name is Kojin, and I'm a co-founder at Robust Intelligence. I'll start a little bit by talking about ourselves and what we do. So Robust Intelligence at a high level, we are born out of indicative research at Harvard. So my co-founder and I were studying the field called robust machine learning, where we were essentially attacking AI models. I think Nick just mentioned AI red teaming. We were doing that as a research at Harvard Lab. And our company is led by Yaron Singer, who was previously a professor of computer science at Harvard, and I was a student. And what we're doing as a company is we're building a product to manage and mitigate AI risk. And we're doing this through continuous testing and real-time validation. And we've been already working with many, many enterprises like JP Chase, Expedia, Cisco, Deloitte, and so on. And as a startup, we've raised a total of 60 million from top VCs like Sequoia, Tiger Global, and In-Q-Tel, which is a government US DoD-backed VC. And we have strong team in AI security. And we've been doing a lot of work on AI red teaming and attacking AI systems. So we have one of our researchers who've been awarded last year's ICML Test of Time Award. ICML is a premier AI conference. We also have researchers who've identified vulnerabilities in LLMs like GPT-4, which was featured on Wired. We also found security vulnerabilities in NVIDIA's NeMo guardrails framework, which was featured in Financial Times. This one was actually an interesting one. It led to a lot of inbound interest from CISOs and CROs. And then also on The Economist, we got featured for our work on data poisoning. So these are all examples that I think Nick mentioned earlier. What we're trying to do is we're trying to actually practically find these issues in production AI systems so that then we can protect, we can build defense around that. We are also working with a lot of institutions. So I think Nick mentioned NIST. We're working together on a white paper for AI security with NIST. We're also working with MITRE, which is a cybersecurity institution known for CVE. And we've built, co-developed what we call an AI risk database with MITRE. You can think of this as essentially like CVE, but for AI. And finally, we're working on open evaluation of popular LLMs. So we've run our test suite against these popular LLMs like GPT-4 and Llama 2, Falcon, and we've exposed this, made this public on our website. So if you're curious, you can check that out. Very high level, I think Nick had a great presentation, but we're trying to solve this problem of AI risk, where AI exposes organizations to unmanaged risk. And we like to think about AI risk in three categories: security, ethical, and operational. And security is like the ones that Nick mentioned, like prompt injection, data leakage, PII extraction. Ethical, model giving out toxic output, biased outputs. Operational, problems like hallucination, data drift, and so on. And the way we're solving this is in two folds. One is AI continuous validation. And the idea here is that we have hundreds of tests that we've developed that are applied to LLMs and other types of AI models automatically to identify these different risks across models in development and in production throughout the lifecycle. And we do this in a way that is compliant with different types of regulations and guidelines that are out there. And once we identify the risks through AI continuous validation, then what we do is we use an AI firewall, which is a real-time protection of AI models against problematic inputs and outputs like toxic outputs, hallucinations, prompt injections, and so on. And as you see here, we've been working closely with different institutions to make sure that we have our product is not only making sure that AI risk management can be done in the organization, but can be also be explained to external parties like the ones mentioned here. Yeah, so that was a little bit about us. I'd like to pass over to Nitin who's going to talk about Databricks.
Yeah, thanks, Nick. Thanks, Gojin. Hi, my name is Nitin Wagh. I'm lead product adoption specialist at Databricks. Databricks is a data and AI company with deep roots in data foundations. So I work with, many Fortune 500 customers on generative AI strategy and the adoption of AI and machine learning. Now, what I've been hearing is there's just a lot of there's a lot of hype, a lot of tools, a lot of technologies available to many AI engineers. This is sort of a new persona, and it's changing every week, right? It's very hard to keep up, and then it's very hard to understand. There's a lot of euphoria, excitement, but there's also nervousness and analysis paralysis. So at the broadest level, if you look at the left, there are these SaaS providers, open source models, a lot of third parties. There is closed source, open source, and there's confusion. And it's good and bad. And on the right-hand side, there are many purpose-built tools, such as, cloud providers have their own tools. Then there are a lot of open source projects like LangChain, Llama Index, and a lot of these Hugging Face. So tools, there are tools, and then there are models. Now, what we are doing is our purpose is to unify this, and so that we can help our customers build generative AI applications faster from inception to production. Next slide, please. Or maybe I can fast. Yeah, awesome. So Databricks is a data and AI company with roots in Lakehouse. So Lakehouse is a building block where your data sits on your foundational, whatever choice of hyperscaler such as Azure, AWS, or GCP. And then we have this Lakehouse platform with Delta Lake as a foundation, where data is now accessible through a unified view across all sort of use cases. On top of that, we have Unity Catalog that allows you to provide governance, and then on top of it, we have this unified platform. So we believe that Databricks is the only end-to-end platform in the world that allows everything from data ingest, data curation, data governance, and every type of AI model building and serving as well. So for those who are in AI space, the building quality AI models start with quality data. So with Databricks, you get every bit of that in a single platform. So having a value of having a fully integrated AI and data platform means not just more efficient development, but preserving data lineage, auditability, and giving you the ability to refine your model feedback loop. So with that, with that as a foundation, we have built Lakehouse AI platform. These are just set of capabilities we built on top of our Lakehouse platform. And they start with, of course, when you think about AI and generative AI, a lot of these capabilities, start with building and preparing your data. Right? Imagine you're building a retrieval augmented generation application. What are the ingredients needed to build that application? If you look at from that lens, you have to first, prepare data for the AI. It requires probably pre-processing and parsing your data, sometimes doing the OCR, and then bringing that structured, unstructured data into a unified lake. Then you need to develop and evaluate the AI. So in the development, we provide sort of tools for developers to maybe fine-tune a model, build a model from scratch through our Mosaic ML platform, or just build an AI application or build an orchestration layer. Prompt engineering is very important aspect in building generative AI applications. And MLflow is our MLOps tool, which is open source. And we are building on top of that MLOps tool things like prompt engineering, prompt evaluation, prompt comparison, and as well as prompt testing. Now, once the generative AI applications is developed, then you have to transition into production. So we have this entire LLMOps platform available through MLflow. So once you are in production, you may have to either use one of the SaaS API, So we have MLflow AI Gateway that allows you to connect seamlessly to third-party SaaS such as OpenAI and centrally manage all your credentials, APIs, your routes, and as well as the logging and caching. And then you can also serve open source models in an optimized manner, so you get like 60% better cost per throughput. And then along with serving your models, you can also serve data, which is a critical component of retrieval augmented generation. And we make that available through our built-in vector search, vector index capability, which is still available in private preview for a lot of our customers. And once these generative AI applications are now deployed in production, then you can use Lakehouse monitoring solution to monitor these models, which will capture all the requests and responses. And then you can also plug in our partners such as Robust Intelligence to look at that data and then provide you different types of codes such as toxicity, perplexity, etc. So just in a nutshell, Lakehouse AI is like a complete platform to build and manage your generative AI applications as well as monitor. So I will hand it back to Nick to take it further. Thank you.
Great. Thank you, Nitin, and thanks, Kojin, earlier. So we're going to move to the discussion portion of today. So earlier, and also I'd just say to the audience, if you have questions, please use the Q&A tool on the right-hand side of the window there, and we'll get to as many of those questions as we can, given the time we have. So obviously, for both of you, I mean, earlier I was sort of talking at a high level about how the risk from generative AI is different from previous versions. I'd be interested in your own words, really, how you would describe the risk of generative AI versus previous kind of modalities.
Yeah, maybe I can go first.
Maybe Kojin, yeah.
Yeah. So I think there are several characteristics that are unique about Gen AI. I think the main thing is that oftentimes Gen AI outputs are made in real time. If you think about ChatGPT, you ask a question, you get a response back. Whereas in traditional applications, a lot of them might have been in batch. For example, every day you make certain predictions, or every quarter you make a forecast about demand or things like that. So and when these decisions are being made real time, and not only against it used to be maybe like PhD machine learning engineers that were consuming the outputs. Now it's literally everyone. Then you won't be able to have human in the loop in the way you had before. So in traditional machine learning applications, we've seen like some companies kind of moderating partial outputs to make sure that programmatic outputs still go out. But that is no longer possible. And so when that's the characteristics of generative AI, what's really important is these controls and guardrails have to happen in real time. And controls have to be codified in a way that is applied to inputs and outputs of AI models automatically. And this is what we call real-time validation.
Nitin, do you have a perspective?
Yeah, I mean, I would do +1 to Kojin. What we have seen is hallucination is a big problem. And, how do you reduce hallucination? And, because a lot of times these models are not deterministic like, traditional supervised learning models. And they're mostly probabilistic. So every time you ask the same question, they might emit different type of answers. Of course, you can control some knobs. But, the biggest problem is hallucination, and with hallucination comes the risk of adding bias, potentially malicious content, so which I think Robust Intelligence platform addresses.
Yeah, that makes sense. So the open source models are a key part of the landscape of foundation models in general. And there's obviously a lot of them available. There's thousands of them being produced, it seems, every month almost. But how do you, when organizations use those, and they will want to use those, how do they uncover the risks that may be inherent in them before they put them into production?
Yeah. great question. So, by the way, just taking a step back, I think at a high level, when we're building our company to think about AI risk management, we learn a lot from cybersecurity and IT risk management, because there's a lot of parallel. And when you think about software, a lot of software engineers use a lot of open source software and libraries, and that has their vulnerabilities as well. And I think there's a lot to learn from that domain about how we can control vulnerabilities in open source LLMs and generative AI models. So in the software land, we have what we call CVE, which stands for Common Vulnerabilities and Exposures, for those who don't know. And basically, every security engineers like to submit CVE on the MITRE website, and that gets propagated to different cybersecurity companies. For example, I think Sneak is a great example, where they scan software libraries for open source vulnerabilities. And there has to be something similar that needs to happen for open source LLMs. Right now, what we're seeing is there are different types of vulnerabilities that are unique to open source LLMs. So, for example, great example is what we call pickle vulnerability. So, a very high level, people use this library called Pickle to serialize open source LLMs and put them on Hugging Face and other repositories. But that library is known to have certain vulnerabilities. So whenever you use them, you probably want to scan for those things. And so the way currently there's no CVE for AI, and that's why, by the way, we're creating this AI risk database with MITRE. But when you're using these open source LLMs, just like you're scanning open source software, you want to scan these models for these supply chain risk, like the pickle file vulnerabilities and other sorts. So translating the software cybersecurity scanning best practices to AI open source model scanning, I would say is one of the things that you want to kind of put in place to address the risks of open source LLMs.
Yeah, makes sense. Kind of key question, I guess, for this whole session, really. Can you talk about some of the best practices you've seen that companies can apply today to their models and applications to minimize risk in their operations? And obviously, we're thinking of the generative AI, and it's obviously very, very early. So these may be experiments rather than necessarily fully fledged production applications. But I'm curious, maybe Nitin, have you got any advice there?
Yeah, I mean, I work with many customers who are on a venture to build these generative AI applications, and traditionally we have been supporting many customers just traditional ML applications. So when it comes to ML, having a solid data foundation is key to successful, machine learning so a generative AI strategy. That is given. If you do not have a solid data foundation, while you can build one use case successfully, which is fine, and so as generative AI, but then as you want to build incremental use cases across multiple users and harnessing data or features, that becomes problematic. Then governing access to data is also important. Governing access to data, models, features. Now with generative AI vector indexes, that is very important to have a successful generative AI strategy. Then, for example, right, I'm working with a customer who has sensitive data on their Confluence, right? In your traditional sense, Confluence pages within a company, you may have access to certain pages, other pages may be redacted. Now, if I'm building a chatbot on Confluence, right, I want to inherit similar ACL permissions. So how do you make that available through your chatbot? So that is a very important implication. So what within Databricks we have this Unity catalog, which is a governance layer where you can replicate a lot of those ACL permissions, and then those are available through your generative AI lens as well for the consumer. So that is a very important aspect when you go from just merely doing a POC to production. Now, there are different phases of development in GenAI applications, right? So first thing is you have to first curate the data set, either for fine-tuning a model or building a vector index. Now, using tags, right, for fine-tune. Let's say you're using a vector index in this Confluence use case. So using tags For example, which data is PIR redacted versus which data is not, which data is sensitive versus not, is important, so that you can expose only the data that a user is able to consume based on their permissions. And then you also have to worry about, as you're amassing this data for fine tuning or training, for correctness, comprehensiveness, so that you get like better system performance for the fine tuned model. Now, next phase is after your data is done, then you get into prompt engineering, and that is very important aspect in generative AI. So, and it generally dictates the outcome of your generative AI application. So things like, what you can also build, like, guardrails within the prompt, right? So that, hey, example, provide a rule book so that it does not respond to toxic content. Or if there's a toxic content, you can ask another LLM to evaluate, okay, if this is a toxic content, and then sort of redact that content before it gets to your consumer, and then log it, and then, like tools like robust intelligence can then detect, and then probably in the future, you have some sort of automation that's built in. Another key area is like prompt comparison, right? Every generative AI model or LLMs are different in terms of what they can respond. So, having a really good, robust prompt evaluation toolchain is very important when you are building generative AI applications. So after the prompts are built, then you put the models in production, or these applications in production, and that's where then you have these systems that probably have to self-correct, right, or self-redact. So in that, in once the application production, then you have to monitor all these prompts that are going in, and then the responses that your LLMs are emitting or the systems are emitting, and then that's when you worry about like fine-grained access in production, so that people who are users who have access to the resources only can sort of get responses from those resources. And then again, you have to monitor these responses, and then tools such as robust intelligence can then sort of have the automation to redact responses on the fly in the production systems. So in essence, you have to worry about managing your models, managing your vector indexes, managing the training data set to build a robust generative AI applications.
That's interesting. That's interesting. Kojan, any thoughts on your experiences and best practices?
Yeah, first of all, I want to echo what Nitin's saying about, I think data governance is first step to having proper AI governance. I mean, AI is built on top of data. So if you don't have proper governance around data, there's no AI risk management, AI governance. And this is where, for example, we integrate with Databricks, and it's really important to put AI risk management as part of the existing workflow, not just the AI workflow, but the whole data management, data governance workflow. And you can do things like access control and things like that. On top of that, there are AI-specific issues that arise. So, for example, in the case of retrieval augmented generation that Nitin was talking about, there's potentially a risk of things like indirect prompt injection, where the idea here is, let's say if you're like a financial analyst and you want to ask questions about quarterly earnings, then you might think about collecting PDFs from a bunch of companies, putting that in a vector database and asking questions. But what can happen, for example, is that in these original PDFs, there can be some small snippets or invisible text that can trick the model into giving answers that are completely different or completely incorrect. And if your analysts are going to make decisions based on those outputs, then that's very problematic. So on top of the kind of the traditional data governance you're doing, you want to have these quality controls that are specific to AI. So that's one thing. I think we've been talking about platforms, but I also want to talk about kind of best practices for organizational structure. And I think in governance, people always talk about 3 lines of defense. And I think this very much applies for AI risk management and AI governance. One thing that we've seen a lot in the AI industry until recent years is that data scientists and machine learning engineers make their own decisions about what is ethical, what is secure, which is kind of a no-no for if you think about other types of risk management. Right? You don't obviously they should be trained on ethical standards and security standards, but they should not be the ones making those decisions on your enterprise behalf, right? So adopting the 3 lines of defense within AI risk management is key. And when we were building our software, we really put that in context. So we have capabilities for individual data scientists and machine learning engineers, but we have things like, for example, model cards, which is essentially like a reporting mechanism where once you run these checks, then we export a report that you can present to the 2nd line, 3rd line, or even external auditors for different purposes.
That makes sense.
Yeah.
So actually, there was a question actually that came up just now actually from the audience, and obviously I'd encourage everybody else to do. There was about a question from Koji. How would you recommend enterprises leverage the AI risk database today? Is it currently possible to bake the AI risk database into the CI/CD pipeline of AI systems to automatically check for vulnerable models and maybe stop them from being deployed?
Yes, the short answer is yes. And we built this exactly for that purpose. We wanted to build, just like in software, you scan things in your CI/CD pipeline, we wanted to do that for AI. So in the AI risk database, we scan essentially all of Hugging Face. So we have these pretty expensive GPU jobs that are running to scan Hugging Face to identify potential vulnerabilities like the pickle one that I mentioned. And those are populated there. And the idea is whenever you're using, for example, a Hugging Face model, then you might want to reference that to make sure that there's no supply chain vulnerabilities there.
Great. A couple of us mentioned red teaming already today. I mean, is this a skill that organizations should be developing? AI red teaming we're talking about specifically. I mean, they should be developing in-house. Is this something they probably look for outside help with? Or I don't know, either of you have, how would you characterize that need?
Yeah, I think, so it's very, I also like to think about this in an analogy with cybersecurity, where essentially AI security is a new field. Just like there are security engineers, right? There will be AI security engineers, and you'll probably see many AI security engineer titles on LinkedIn 3 years from now, 5 years from now, and AI security will be as big as cybersecurity, if not bigger. And when we think about how the cybersecurity industry evolved, of course, different enterprises have CISOs and security folks in the company, but for a lot of the expertise, they rely on external vendors, right? So for example, I mean, there are so many different types of security, like IoT security, container security, like microservices, hardware security, like all these different types. And it's really, really hard for an individual company to build expertise in all these different domains. And it's very similar paradigm with AI security. AI is an overload term. There are so many different types of AI. Like, I mean, LLMs is one. Now there's multimodal models. Obviously, there's the classic AI. There's like audio, like so many different types, and so many different tasks. Content generation, but also summarization, translation, speech recognition, and it's really hard for an individual company to develop these types of capabilities, and this requires not just like manually querying these models, but capabilities that we call algorithmic AI red teaming, where the idea is you want to leverage algorithms to kind of feed in different types of data to probe the model to see what kind of vulnerabilities you can find. And so those are things that are difficult to develop. It's really important to have awareness about the importance of these things, but you want to balance, kind of leveraging your internal domain expertise, but also relying on external AI red team.
Yeah, I can add a little bit my perspective as well, and Kojin, you're the expert in the area. But what I've seen is a lot of the customers that I deal with typically rely on these model providers to ensure that their models are safe, right? For example, I've seen customers trusting Azure OpenAI more than OpenAI, And some of the regulated industries that we deal with, right, as Databricks, they do not even sort of want to use third-party SaaS providers. And sometimes they focus on using open source models, but then some security sensitive customers do not want to like use the open source models produced by other providers, but then that's when they try to build this model from scratch, right? Which everybody thought is like out of the out of their budget, out of their realm. But with Databricks acquisition of Mosaic ML platform, we are working with like bunch of customers in regulated industry who would like to like ensure that they have full control on the model assets. They have full control on what data is being fed for machine model training, right? So that they can eliminate those risks from even getting penetrated into the model, right? So that is another paradigm, pre-production, so that you can control your own supply chain, so these effects do not happen.
Yeah, it's amazing.
It's very much like shift left. And
yeah,
it's like very much like shift left in cybersecurity, right? Like you want to shift left the risk to the earlier parts of the life cycle, and we want to adopt like similar principles in AI security as well.
Yes,
sounds good. It's interesting, Nitin, what you were saying as well. I mean, about the number of companies you're coming across, and I'm sure Kojin is as well, and we're coming across that are interested in building their own models from scratch. It's it may be slightly surprising, and it's not for the faint of heart sometimes, but it's certainly real, and I think it's it's going to continue. And obviously, a lot of people are going to rely maybe on more fine tuning, and so they're relying on models that are already out there, and then tweaking them with their own data. And then obviously, new models come out daily and intradaily. And as they do, how organizations best how can they ensure that either no new risks are being introduced when they use those models, or at least trying to mitigate against the as much as they can? Is that how would you advise companies go about that?
Yeah, so I can go first on a high level. Our approach. So again, as I was saying, these model consumers or customers depend on providers like us, who they trust, and robust intelligence to provide them the guidance, and then point them to models that are safer than others. I mean, Hugging Face like produces these models at like such a breakneck speed that it's very tough to even for us to keep up. So our approach is, of course, we have created these. We have created this AI gateway, which is a product, essentially like an API gateway, where customers can connect to like third-party SaaS providers such as Google, Azure, in future it will be AWS. Now, and these customers typically trust these providers to provide, models that are safe and regulated. Beyond that, from the open source, what we have done is we are only focusing on curated set of models, such as, for example, we are partnered with Facebook or Meta on Llama 2 launch. Right, so Llama 2 launch is one of the models that is available through Databricks Marketplace, because we believe that can be, of course, we know that it can be used commercially, as well as it's safer to use in generative AI purposes. So we are putting these models on our marketplace so our customers can consume. So Llama 2 being one example, but you will see like series of such models that we trust and feel that are safer in that spirit. And hopefully, in future we may build our own model as well.
There's actually a question about this related to this. It's from the live question. So, is there a best practice or guide that developers should instrument in their applications to omit about the health of the models they rely on or consume? I don't know if Kojin, you can take that.
Yeah. So I think there are a lot of best practices and kind of concepts from software we can borrow, and there are things that are unique to AI as well. So in terms of developer practices, best practices like shift left is definitely one. Don't wait until you put your models into production and then let it break. Try to check those things up front when you're building the models, or even when you're starting to explore different Hugging Face models. Check for those vulnerabilities up front. TDD, test-driven development, very much exists in software. You learn it in CS 101. You don't learn it in AI 101, unfortunately. So the idea is write tests as you are developing, and even earlier than that. So TDD is another one. CI/CD, I think there was a question around that, but even with models, you know, like their Databricks has MLflow, but you can use like these tools to kind of build ML models and manage different versions. But when you're doing that, make sure that you continuously test these models, and to make sure that at every point in time, these models are ready to go out into production. So embed testing as part of your CI/CD workflow. So those are all concepts you can borrow from software. What's different in AI is that AI models behave very differently once they're put in production as time passes. Software more or less kind of remains static. You know, you can read the code and understand its deterministic behavior, but AI models change its model behavior based on the data that changes. And sometimes, especially if you're using third-party AI models, the models themselves change. For example, ChatGPT retrains itself every week, and there's no concept of backwards compatibility in AI. So you have to be responsible for when ChatGPT retrains itself. You have to be responsible that ChatGPT still remains to behave correctly in production, right? So this is where, you know, I mentioned earlier, but the concept of continuous validation becomes important. Not only checking for these things in development, but continuously validate the behavior of models and how it's behaving against different data in production. And I think actually Matej from Databricks, the CTO of Databricks, he had a paper where he examined ChatGPT behavior and saw that certain prompts don't behave correctly as, you know, the model gets updated. So those things you want to check for in production as well.
Makes sense. Different kind of question, maybe a slightly higher level. What are the challenges you see for companies looking to adopt new processes around novel AI models and technologies? I don't know if Nitin, you can take that.
So I mean, see, with the generative AI, there are a different set of challenges, right? Traditional MLOps was like very much baked in. You know, there was like CI/CD processes, promotion, right? There was like code promotion, model promotion concepts. But with generative AI, there are like few concepts that have got in the mix, right? One is like this whole prompting. And so the challenge is, how do you manage and maintain, similar to how you would manage a model versioning, you know, and Kojin just touched upon it, like, you know, ChatGPT has been changing over time. And then how can your prompts adapt to that changes, right? So how do you like manage and maintain this versioning of the prompts that you are sort of promoting into your production? That's one challenge. Second aspect that has come along with the generative AI is the vector databases, right? The rise of vector databases, which was traditionally used for similarity search and other, like, you know, semantic search problems. But with the RAG, now they have become prominent. You know, in traditional MLOps, we had feature stores. Now we have feature stores and we have vector indexes. So how do you manage the life cycle of those vector indexes? How do you sort of, you know, promote them, use them in development, and then promote them to production? You know, make sure that there's like a sort of a compliance and fine-grained access control around those vector indexes, because, you know, it's sort of production data. So there are like these two extra challenges and you know, best practices that a lot of our customers have to adhere to compared to the traditional MLOps. Incidentally, we just released a new book we call as Big Book of MLOps version 2, that also includes LLM ops, that also adds, you know, these, you know, focuses on these two additional facets and generative AI MLOps.
Interesting. Another question actually live from the audience, and if anybody else has questions, obviously please enter them. It's maybe for Kojin more. Would you recommend security teams leverage threat modeling for their security assessments of AI systems? If so, what are some of the key things to consider in those threat models as they pertain to AI, and how would you do this at scale when new AI solutions seems to come up every single day? A lot there.
Yeah, great question. So just, you know, taking a step back, like when we started the company, we had a lot of interest from like VPs of data science, and everyone had like AI or data science in the title. Now, I think starting like exactly about a year ago, after ChatGPT got introduced, we're getting a lot of interest from people with the security title, the risk title. And I think this is showing how AI has kind of graduated from a kind of a lab experiment to becoming a top of mind agenda for CISOs who might not have been focused on AI before. And what this means is that probably in security orgs, you have SIEM, right? SIEM, to manage different security incidents and events. And you are seeing a gap there. AI security is a gap, and we're hearing this a lot from CISOs and CROs. So the first thing is to recognize that there is an unmanaged risk within the organization, and that has to be part of the, as you say, the threat model, the threat vector. And the good news is that we are seeing security organizations like institutions increasingly introducing different standards. So MITRE has now MITRE Atlas, which is an AI security standard, and OWASP, which is another cybersecurity organization. They recently released OWASP Top 10 for LLMs, where they outlined the top 10 vulnerabilities for LLMs. And so these are all great sources to understand the different threat models and what you can do about it. And for example, for us, like we've been developing our AI firewall to be compatible with OWASP Top 10, for example, to detect against like prompt injection, model denial of service, model theft, and all these different types. So I think looking into those standards that are coming up would be a great first step to thinking about AI security threat models.
That makes sense. Observability is one of those terms that means, well, like all terms in technology, starts meaning one thing and then expands to mean lots of other things. But how would you characterize observability and proactive risk management working together so companies can deploy LLMs and other kinds of foundation models and other kind of models at scale?
Yeah, I can go ahead and probably Kojin, you can add. So I think observability and the risk management, they go hand in hand. In GenAI, a lot of that depends on the the data monitoring, right? It's a data monitoring problem. So early in the life cycle on the left, of course, you can manage a lot of your risk if you're planning to fine tune or pre-train a model to weed out those bad aspects right from the get-go, so that your data is balanced and clean, so that your model is fine tuned with that in mind. As you go to the right into production, I think a lot of that observability comes from managing, what your models are producing, right, and what the requests are being fed in. So you understand like what are the popular questions, what are the popular demands, and then what are the sort of some of the responses. So you track them, and we allow our customers to track them in our lakehouse, right, which is just a delta table, and then the volume can grow, and then we have built like basic capabilities, but then we rely on partners such as Robust Intelligence to look at those prompt request responses and then make sure that there's nothing malicious, and then flag them, or there can be a signal for retraining or fine-tuning a model so that those do not reoccur. Kojin, you want to add something?
Yeah, I think it makes a lot of sense, and they go hand in hand, right? Like I think observability is about understanding the health status of current models that are in production. I think Nick, you mentioned like proactive risk management, and I think the word proactive is really important. Where I think observability tend to focus more on the kind of post-production model health, model performance. Risk management should happen a lot earlier at the point of choosing the right models and choosing and during development. So I think when they're combined together, they can be very powerful.
Yeah, and I would just one more point, like proactive risk management also is rooted to data, right? So sometimes our customers demand like PII redaction, right? You want to redact certain data which should not be exposed to customers. So PI reduction is very important in pre-training phase as well as in the post-training or deployment phase. So, for example, if you're building a RAG application, you may want to when a user throws a query and if they do not have access to PII sensitive data, then your vector index should be able to sort of filter out, pre-filter the data that they should not have access to before running the similarity search, so that the answers are always clean and they do not have access to that data. So that sort of control is very important, and it's a nuance, but when you go to production, these things definitely pop up.
Cool, and a few minutes left. So just the final question, really, and this is a hard one, given how rapidly everything changes by the day in generative AI. But where would you see AI risk management being in sort of 18 to 24 months' time, Kojin?
Yep. I think this relates to some of the responses that I've been giving, where I think AI security, AI risk management is going to be like cybersecurity, IT risk management, in the sense that it's going to be its own market. It's going to require its own expertise. There will be, AI security companies, AI risk management companies, and there will be a whole industry. And for example, like internally, we say, we want to be like the Palo Alto Networks of AI security, or Cisco of AI security, and there will be companies like that. And so just, in 18 to 24 months, and also like in 5 years, 10 years from now, the first thing to acknowledge is that, this is not going to go away, or it's only going to get bigger and bigger. And we will see more regulations and compliance, like the SOC 2 or GDPR analog. And as Nick introduced earlier, there's now NIST AI Risk Management Framework. If you look at the EU, there's the EU AI Act. We're going to see a lot more of that. We'll see a lot more enterprises adopting to that, and as a result, a lot of startups adapting to that. So, yeah, I think those will all be changes that will be happening, and the whole ecosystem with the actual, like enterprises and companies that are building the applications, the companies that are providing the platform, like Databricks, and then companies like us who have the expertise in AI security and AI risk. Those need to come together to realize this AI risk management at every company.
Nitin, what's your perspective? You've got about a minute to sum up the future.
Yeah, I mean, I plus one to what Kojin said, but our view is, after this, we are in the hype cycle. We are in like top of the hype. So there's a lot of excitement about, these SaaS providers. But as and we have a lot of customers in like doing the POCs, but as they graduate to production, what we are seeing is, a lot of these legal governance, security teams are, getting in the mix. And what we believe is in the future, enterprises will adopt the, not these large models, but like smaller models, very task specific, who that customers have, total control on, and then they'll be really good at like, one type of thing, right? Which probably enterprise needs. Like if I'm a customer support agent, I may need like a model for giving promotions through generative AI, right? Suggest me a promotion for my customer that I'm talking to, right? It's a very common use case. So that does not require like a massive model. So the smaller the surface of that model, smaller the number of parameters, I think you can probably control the security and governance aspect of that model. So we believe in fullness of time, in like next 12, 18 months, there's going to be plethora of these small models. And, as long as these performance are met for individual tasks with these large SaaS providers, customers will be able to control the risk and the exposure, and then there'll be better like governance. So it will become like everyday AI that we have been seeing for many years.
That's great. Well, we're at time. So thank you, Nitin from Databricks, and Kojin from Robust Intelligence. And thank you very much for our audience for engagement and some great live questions. And we'll try and get back to you with any other questions we weren't able to get to. But for now, we want to thank you very much for your time.
Thank you, everyone.
Thank you, everyone.